All right, here we go, guys. How do you divide complex numbers? Well, it's not actually dividing, and I know you can use a calculator, but try not to use a calculator. The way you do it is we're going to multiply by the denominator's conjugate. Do you guys know what that word means, conjugate? Okay. Complex numbers come in pairs, the plus minus. So if I tell you what's the conjugate of 3 plus 2i, this is a real component, you just change the polarity of the imaginary component. So the conjugate of 3 plus 2i is 3 minus 2i. And that's all. That's all it is. So if I give you another number like negative 5 plus, I don't know, I'm just making this up, square root of 3 with an I on it. I'm going to put the I in the front. And I tell you what's the conjugate of that. You just change the polarity of the imaginary part. So negative 5 minus I square root of 3. Does that make sense, guys? That's what the word conjugate means. So how do you divide complex numbers? You do a hack. You're going to multiply this by the conjugate of the denominator. So since that's 10 minus 9i, you're going to go 10 plus 9i divided by 10 plus 9i. When you do that, so let's see, negative 28 minus 11i times 10 plus 9i. So let's see, negative 28 times 10. I think that's negative 280. And I make mistakes all the time, guys. So if you see a mistake, let me know. Negative 28 times 9. I don't know. Off the top of my head, I don't know. Let's see, 72. 9 times 2, 18. Plus 7, 18. 9, 20, 22, 24, 25. 252. So let's see, what is this? Minus 252i. Now I make mistakes all the time, so check my work. What's 11 times 10? Minus 110. I. And 11 times 9, that's minus 99i squared. Everything okay so far, guys? All right, so let's see. Remember that I squared, and I haven't done the denominator yet. Don't worry, we'll do that right now. I squared is the same thing as negative 1, so this is going to turn to a plus 99. So that should be pretty easy to do with this guy. So negative 280 plus 100 is negative 180, but I didn't do 100, I did 99. So it's going to be negative 181. And then 252 minus 110, 252, 352, 362, minus 362i. Okay, and let me see. The denominator, see how we have 10 minus 9i, 10 plus 9i? So that kind of acts like a difference of squares type of thing. John, what are you talking about? This looks like a minus b times a plus b. That is the difference of squares. 10 times 10, 100, minus 9 times 9, 81i squared. 100 plus 81, that's going to be 181. Because remember, I squared is negative 1, so that turns that circle into a plus. You guys know what I'm talking about? So in the bottom of this, so I'm going to say so, negative 28 minus 11i divided by 10 minus 9i is nothing more than negative 181 minus 362i divided by a positive 181. And if it does go in, we reduce it, and it does. So it looks like it's negative 1. And then 181 times 2, let me make sure, 18 is 36. Yep, it's perfect. Minus 2i. So there it is. That's my answer. And we can verify that that's our answer. We take a calculator here. And let me reset it. This is from last time. And what was the problem already? I already forgot it. What was the numerator? What did I have in the denominator?
10 minus 9i.
And yep, there it is. Same thing. Don't use the calculator to get this out of the way. Try to do as much as you can by hand and use the calculator to verify. What's up, miss?
Can you go back on how you simplified the fraction to 1 minus 2i?
Yeah, I just looked at the 181. And I said, 181 divided by 181, that's 1. See? So negative 1 because of that sign. Anytime you're dividing by one term, you can just take each term like this individually. And then I saw these right here, 362, 181. And I'm like, oh, 181 goes into 362 twice. I didn't do that in my head mentally. I saw the 18, and I go 18 plus 18 is 36. And then I saw that 1, and I saw that 2. 1 plus 1 is 2. So then I'm like, oh, 181 must go into 362 twice. You know what I mean? And there it is. And from that, I was able to get that equation right there. I guess you could also say 180 plus 180 is 360. But it's 181. So add another 2. How do we feel, guys? All right, same thing with this. 9 minus I over 5 plus 9i. Maybe we should have started with this one because this one looks like the numbers are easier. You're going to multiply this by the conjugate of the denominator. 5 minus 9i over 5 minus 9i. Remember, that's a 1. So anything times 1 is itself. You know what I mean, guys? So that's how you deduce this. So let's see. Negative 9 times 5. What's that? Negative 45. Negative 9 times negative 9i. So I'm going to have plus 81i. And then negative I times 5 minus 5i. And let me know. I make mistakes all the time. Negative I times the negative 9i squared plus 9i squared. All over. The denominator is going to be 25. And the negative positive 9i times the negative 9i minus 81i squared. But remember, I squared is equal to negative 1. So this guy is going to change the polarity to a plus. I guess circle the whole thing. So it's going to be a plus 81. 81 plus 25. Well, let's see what that is. I guess let's do the numerator first. I see this guy right here. That's going to be a negative 9. So 45 minus 9. 45, 55, negative 54. And then 81 minus 5. What's that? 76. I should have put the I in there. And then 25 plus 81, 81, 91, 101, 106. I see a 106. This does reduce. I make mistakes, guys, so let me know if I'm wrong. Let's see, 50, 50, 108. Nope. I guess we'll just do it like even. Negative 54 over 106 plus 76 over 106 with an I on it. So let's see. I'm just going to reduce these by 2 until I can't reduce it anymore. So 54, what's that, 27? If 2 goes into 54 27 times. 27 over 53. Plus, and I'm just reducing it by 2, guys. How many times does 2 go into 76? Let's see. 35, 36, 37, 38. 38 over 53 with an I on it. I don't think I can reduce it anymore. It feels wrong to me, but hey, no, Yanni, that's a demerit. Let's see if it's correct. So what do I have in the numerator again? Minus I? Minus I. What do I have in the denominator? 5 plus 9i. All right. Turn it into a fraction. Oh, did we get that? Okay. It felt wrong to me because it just was weird. But yeah, there it is. It's correct. Cool or not cool? Okay. All right, guys. You guys remember how to plot imaginary numbers? No? All right. So it's a hack. I feel it's a hack. Instead of calling the y-axis, guess what they call the y-axis? The imaginary axis. And then the x-axis, they call that the real axis. So you graph the real component and you graph the imaginary component. Chop, what does that mean? You see how I have negative 4 minus 8i? What's the real component? So negative 4, comma, what's the imaginary component? Negative 8i. You put the I in there because it's still imaginary. So you're going to graph negative 4, comma, negative 8i. Negative 4 and then negative 8 is way down here. So that's the point. There it is. Sometimes not. It depends. Sometimes they'll call this a vector, and they'll stretch it from the origin, and they'll stretch it like this, and they'll say that right there is -4 minus 8i. It just depends. I did not check which one delta had first, if they had the vector portion or just the point. One of those two. I'm gonna go ahead and erase it because I think it's probably this one that they just put. But just keep an eye on that. Cool or not cool? Okay. Plot the complex number -1 plus 7i. All right, here's -1. See how they call the y-axis imaginary? So there it is. That's that point, -1 plus 7i. Sometimes they'll do a vector. I guess I can do the vector just in case, because I think the modulus is coming out in a little bit. And there it is. Cool or not cool? All right, let's go to the next. Yeah. Okay. What is a modulus? All right, guys, relax. Have you ever heard this word before? Okay. Have you heard it in with imaginary numbers? A modulus is just kind of like saying, what's a hypotenuse? John, what are you talking about? That's the hack. Just wants to know. So find the exact, so whenever you see these absolute value, that absolute value means modulus. Find the exact value of 9 plus 6i. So I'm going to exaggerate quadrant 1. Here's quadrant 1. And I'm going to say, I'm just going to pick a random point, guys. I'm going to say that point is 9 plus 6i. Here's 9. Here's 6. Stretch it from the origin. Go like this. And all you're going to do is find the Pythagorean theorem. Burnt orange. Sometimes you can break it up into x and y components. You don't have to. So this is 9. This is 6. So to get the modulus, you're going to go square root of 9 squared plus 6 squared. 9 squared is 81. 6 squared is 36. 81, 91, 101, 111, 117. Square root of 117. Done. That's it. That's all that modulus is. Anything crazy? Sometimes it breaks down. I don't think that 117 breaks down. No. All right. This one. I think this one does break down. Here's my grid. -3 plus 2y. So I'm going to exaggerate quadrant 2. I'm going to go, this is a real axis. Here's my imaginary. -3 plus 2y, point. -3 comma 2y. Or if they write it in vector form, they can write it from the origin to that. And -3 plus 2i. Here is the x and y. This is -3. This is my 2i. You just care about the number, guys. So the modulus is equal to square root. You can actually just write this as well. -3 squared plus 2 squared. Chav, why aren't you writing the I? Because you just care about the magnitude. Does that make sense? Okay. I know, guys, not the most exciting stuff. -3 squared is 9. 2 squared is 4. So this is just the square root of 13. You can also say absolute value -3 plus 2i. Close it, equals square root of 13. Keep an eye out for that on the ACT, SAT. I think I put SAT problems here. Yeah. The SAT has a no calculator portion. The ACT, I don't know if it does. I don't think it does. Yeah, the whole thing. The whole thing is calculator, right? Oh, the SAT is the whole calculator now? There's no calculator portion?
When they change it to online, it's all calculated now.
Okay.
No, we appreciate it.
So I don't even know if these type of questions will be in there because you can just type it into your calculator.
There's no imaginary numbers.
There isn't?
Not on SAT.
So maybe the SAT is getting easier. I don't know. Yeah, that's already yawn number 2 there, miss. All right. It says if the expression 4 minus 2i over 1 plus I is rewritten in the form of a plus bi, where a and b are real numbers, what is the value of a? Ooh, I like it. Okay. Well, let's see. 4 minus 2i over 1 plus I, and the only way to divide those is to multiply this by the conjugate, 1 minus I, 1 minus I. The university probably will ask you for this question in a math placement exam. So let's multiply the numerator here. 4 times 1 is a 4. 4 times negative I is a minus 4i. 2i times 1 is a minus 2i. And 2i times a negative I is a plus 2i squared. All over, and in the bottom, you're going to get 1 minus I squared. We're still okay, guys? All right, let's see. This 2i squared. Yeah, someone close the door real quick. Sorry. So that 2y squared, change it to negative 2. Sorry, I got distracted there. Remember that I squared is equal to negative 1, guys. So that's all I'm doing. I just replaced the I squared with negative 1. So 4 minus 2, that's a 2. So I have 2 in the numerator. And then 4i minus 2i, that's going to be minus 6i. And on the bottom, I squared is negative 1. So minus a negative 1 is 2. And because I'm dividing by one term, 2 divided by 2 is 1. 6 divided by 2 is 3. So 1 minus 3i. They could have asked us a lot of questions. They could have asked us what is a plus b or what is b, but in this case, they just want to know what's the value of a. If there are no mistakes, which I don't see any mistakes, the value of a is just 1. Do you guys want to see if you guys can do SAT Q2 on your own? Yeah, take a 1 minute head start and we'll do it together in a little bit. Did you guys get what I got? And then you can reduce this. 5 goes into 30. That's your b right there, because remember, a plus bi. 5 goes into 36 times. 5 goes into 25 5 times. So 6/5 I. So b is... What do you guys think? Not bad, right? Pretty straightforward. All right, guys, that's it. Take care of the delta. And we're done. Easy day.